Linear momentum. For a particle, the linear momentum is equal to m times v. M is the mass of the particle in kilograms and v is the speed in meters per second. So the unit of p will be kilogram times meter per second. If you have a system of many particles, you will do the calculation of the linear momentum of the system. P of the system is equal to the sum of all linear momentum. So it will be sigma mi vi. So m1 v1 plus m2 v2 plus m3 v3. It depends how many particles you have. And if you want to calculate the linear momentum of the center of mass, it would be equal to the linear momentum of the system. Now we can apply the second law of Newton. It comes from this. The second law of Newton that you know already, which is the sum of forces is equal to m times a, comes from this. It's the derivative of p, which is equal to sum of the external forces. And so this can be also replaced by delta P over delta T. Okay? Equals sigma Fx. The theorem of the center of inertia would give us the following formula. Sigma of the forces is equal to m times the acceleration of the center of gravity, A of g. Now, the conservation of linear momentum, we can see it in different cases. First, if we have an isolated system. In this case, there's no external forces, so we can say that sigma f is equal to 0. We put a vector over 0 because the forces are also vectors. So a sum of vectors is also vectors. Okay. But we also know that dp over dt is equal to this. So it means that dp over dt is equal to 0 because this is 0. So if the derivative is equal to 0, it means p is constant at any time. P equals constant. So therefore, the linear momentum of an isolated system remains constant when time varies. Now, during collisions or explosions, external forces are neglected with respect to impact forces. So you have two types of collisions, which are elastic and inelastic. For the elastic collision, the kinetic energy is conserved. So we can write EKI equals EKF. Initial kinetic energy equals final kinetic energy. But if the collision is not elastic, so it means a part of the kinetic energy is being converted into heat or other types of energy. So it's not conserved. So in that case, we can say that EKI is different from EKF. We will take an example on elastic collision with collinear velocities. These are two solids with different masses. Let's say this solid has a mass m1 and this one has a mass m2. They have two collinear velocities. So this is the first velocity for m1, and this is for the second one. Okay, so this is v1 and this is v2. Um, After the collision, after they touch each other, the velocities of both change. The velocity of the first one becomes v prime 1 and the second becomes v prime 2, respectively. So, but there's a conservation of linear momentum, which means that P initial is equal to P final with vectors. And then we can apply that. So it means that if P initial is equal to P final, it means that we can write M1 V1 plus M2 V2, okay? يعني, which means P1 plus P2 equals, okay, so I will write it here, P1 plus P2 equals P prime 1 plus P prime 2, of course with vectors. The new linear momentum is m1 v prime 1. The mass is the same, the mass didn't change, it's just the velocity that changed, and v prime 2. Now I will just change the places. I can remove the vectors, okay? I can write this again and remove the vectors because they are collinear. So I wrote the same thing again, but without the vectors. And then I can group M1 parenthesis V1 minus V prime 1. So I wrote this here. And I will bring this here. So it will be M2 factor of M2 factor of V prime 2 minus V2. Also, because the collision is elastic, so now you will write, since the collision is elastic collision, we can say that 1 over 2. Where does this come from? It means that the kinetic energy, the initial kinetic energy is equal to the final kinetic energy, okay? So we applied two things, the conservation of linear momentum and the conservation of the kinetic energy. This is the initial kinetic energy, which is equal to the final kinetic energy. So we just change the velocities. And then we can regroup also. We can simplify by 1 over 2. The 1 over 2 is gone, and we get, okay, so 1 over 2 is gone here and here and here, because they are all the same factor. And I bring M1 factor of V2. I bring this here, it becomes minus. Okay, if it's not clear, I can explain it again. V prime, okay, M2, and okay, that's it. So now I have here the formula a2 minus b2, so it will be a plus b factor of a minus b. So it becomes m1 factor of v1 minus v prime 1 factor of v1 plus v prime 1, and the other one will become v prime 2 minus v2 factor of v prime 2 plus v2. Now I divide this, okay, this thing that we obtained by this. I divide this by this. Divide them. يعني you will put m1 factor of v1 minus v prime 1 this over this equals this over this. And from that, if you do the calculation now on your paper and simplify. Pause the video and do the calculation and simplify. And then what do you get? You simplify, this and this is gone, and this and this and this and this is gone. So you will have v1 plus v prime 1 equals v prime 2 plus v2, which means that I can write v1 minus v2, I got this here, equals minus v prime 1 plus v prime 2, okay? And we previously found that m1 v1 minus m2 v2 equals m1 v prime 1 plus m2 v prime 2. Okay? I mean this one. We found that m1 v1 plus m2 v2 equals m1 v prime 1 plus m2 v prime 2. I forgot the prime here. Okay, so I will multiply this thing by m1 times m1. So it will become m1 v1 minus m1 v2 equals minus m1 v prime 1 plus m1 v prime 2. And I will add this to the other formula that we found. This formula m1 v1 plus m2 v2 equals m1 v prime 1 plus m2 v prime 2. So I will write it here, m1 v1 plus m2 v2 equals m1 v prime 1 plus m2 v prime 2. This is the first relation we found when we did p initial equals p final. So if I add these two equations together, I just add them, okay? I add the first equation to the other. I get 2m1 v1 plus m1 minus m2 minus m1 v2 equals this and this are gone, okay? Because you have m1 v prime 1 minus m1 v prime 1. So I will get m1 v prime 2 plus m2 v prime 2, which is, I can put them in factor, m1 plus m2 factor of v prime 2. So from this equation, I can get v prime 2. V prime 2 is this divided by m1 plus m2. Okay? And then you can, okay, I will do it. So you get v prime 2 equals this over m1 plus m2. And then you can write it uh, v1 alone and v2 alone. So this is a factor of v1 and this is a factor of v2. So it will become v prime 2 equals 2 m1 over m1 plus m2 v1. Okay, I put v1 alone, and for the other factor for v2. Okay, if you are doing the calculation on your paper, you can see it. And then, so now you have v prime 2. And we also have this equation, this green equation here. It's the most important. If you substitute v prime 2 inside this equation, you will get v prime 1, because you can get v prime 1 from here. So I won't do the calculation. You will do it. Just replace v prime 2 inside this, and you will get the value of v prime 1. V prime 1 will be this, m1 minus m2. This is not to learn by heart. You just have to know how to find it. Okay, so we found now the final velocities after the collision. Now we can take many cases inside this. For example, in the first case, if I have m1 equals m2, what if m1 is equal to m2? What does that mean? If the two bodies have the same masses, it means they will have the same velocities. They will exchange their velocities. Here in the case that we did before, they did not have the same mass. Okay, we said that m1 has a mass different than m2. But if they have the same shape and the same mass, they will have the same velocities. So we will have v prime 1 equals v2. It took the velocity of the first, I mean the other body. And v prime 2 will have the velocity of the first body. So this is how they exchange velocities. And you can prove that by calculating here. Okay, I gave you the answer without calculating. I can verify, I can calculate v prime 1. I have now the equation. So v prime 1 equals m1 minus m2. Okay, you have it. Replace here. Replace if m1 equals m2. So it means m1 minus m2 is 0 because they're equal. So it's 0 over m1 plus m2 v1 plus 2m2 over m1 plus m2. So m1 plus m2 is actually 2m2 also, because m1 is equal to m2 v2. So it's this one is 0, this one is 1, so it will be equal to v2. Okay, 0 times v1, 0, this is gone, and this is 1, 1 times v2, v2. And v prime 2 will be, you replace in this formula here. Again, 2m1 over 2m1. You can replace m1 plus m2 by 2m1 v1 plus 2m2 over 2m2. Actually, uh, here here in the formula, it's M2 minus M1, okay? Correct it. You will get M2 minus M1, okay? So M2 minus M1, which is 0, so again 0. So here we get 2M1 over 2M1 is 1, so it will be V1. So V prime 2 equals V1, and V prime 1 equals V2. As we said, it's correct. Okay, so this is a special case if they have the same mass. Another case, I will take another case now. If the second body is at rest, what does that mean? Yani you have two bodies, the body 1 and the body 2, but the body 1 is moving with velocity v1, but the second body is fixed. It's not moving, so the velocity v2 is 0. In the case, if v2 equals 0, this is a special case, okay? We can also calculate v1 and I mean v prime 1 and v prime 2. Let's calculate them. V prime 1 would be m1 minus m2 over m1 plus m2 v1. And because v2 is 0, so this will be gone. So we will only have the first term. This would be v prime 1 in the case if the second body is initially at rest. And v prime 2, let's calculate it using this formula. It would be 2m1 over m1 plus m2 v1. So this is a special case. How do I know where the two solids move? So you have two solids, they did a collision, but after the collision, which direction will they go? It depends on the mass. If the mass of m1, if the mass of the first body m1 is greater than the mass of the second body, so the two solids will move in the direction of v1. Okay, because the mass is greater, so the velocity will be at its direction. And if m1 is less than m2, so v prime 1 will be opposite sign of v1, and v prime 2 will have the same sign of v1. And the last case, if m1 equals m2, if they have the same mass, we said that we will have new velocities in the first case, okay? In the case they both have a movement. But now we are studying the second case where the second body is initially at rest. So v prime 1 will be equal to 0 because the body stops, and v prime 2 will be equal to v1. And the vector v prime 2 will have the same sign as v1. Okay, thank you for watching. This chapter was required for an exam, and a student asked me to do this video. Hope it helps. Thank you for watching. Goodbye.